objectives for today's presentation is to give you a brief overview of different types of math that's used on IDOT projects. We'll start with some basic math principles and some practical problem-solving applications later on in the presentation. We'll also cover types of measurements used for IDOT construction projects, some common abbreviations, also some common types of shapes that you'll encounter on construction projects, and hands-on math and problem solving later on in the presentation. The basic types of math used on IDOT projects include addition and subtraction, multiplication, division. You'll also encounter situations, situations where you'll need to have averages calculated, fractions, percentages, and one component of math that's not typically associated as a mathematical component is stationing on IDOT projects. We'll get into a little bit of how stationing works, where it's located on the project, and how it can be used. Typical types of measurements you may encounter on an IDOT construction project include lineal measurements such as inches, feet, tenth of a foot, yards, miles, and stationing, as I've mentioned. Some of the common applications for that may include, but are not limited to, lineal measurement is curb and gutter, your storm sewer applications, pipe under drain, as well as electrical wiring. Area measurements typically include square feet, square yards, acres, or some other type of area measurement that could be stipulated specifically for your contract. Some typical applications for area measurements would include concrete base course widening, driveways, sidewalks, seeding and sodding, or median surface. On the type of work you're doing on an IDOT contract, you may encounter some volumetric measurements, which include cubic feet, cubic yards, or gallons. Some of the typical applications for that would be trench backfill for storm sewer. Certain concrete structures would be a volumetric measurement, as well as supplemental watering for seeding applications. They also come across weight measurement requirements, which are typically in pounds or tons. Your fertilizer mixtures would be a pound item. Bituminous asphalt mix would be a tonnage item. Your typical abbreviations for units of measure are included on this slide here. For length, that would be your lineal feet. You have the abbreviations for inch, feet, yard, mile, and station. Your area abbreviations, we list here square feet, square yard, acres. For your volume abbreviations, you typically run into cubic feet, cubic yard, or a gallon. For a weight measurement would be pound or ton. And some of your other measurements you may run into each item, which would be unit of measurement. If it's a quantity based on one each, or you'll list the number and then each designation. Unit diameter, hour, or even a daily calculation. Basic shapes you may encounter on a construction project would be a type of a triangle. You may run into this if you're measuring area for seating and sodding, pouring concrete, or even a removal item if you're measuring for removal. The basic types of triangles include an equilateral triangle, an isosceles, or scalene triangle, and those are determined by the length of the sides on the triangle. For your internal angle measurements, they're named the right angle triangle, an acute triangle, or oblique. A little bit more information or in depth on these types of triangles. For the equilateral triangle, if you notice, the sides are designated by the lowercase letter and the angles are designated by the uppercase letter. And the length of all three sides of an equilateral triangle are the same length. So side A is the same as side B, which is the same as side C. And all the angles are a 60-degree angle for an equilateral triangle. For an isosceles triangle, A and B are the equal sides, and C is not the same as A and B. But all the angles will still add up to 180 degrees. Scalene triangle, all three sides are unequal, which means they're not the same length. Again, all the angles will add up to 180 degrees. On a right triangle, the vertical and horizontal sides comprise a 90-degree angle. For an acute triangle, all the angles are less than 90 degrees. However, they will add up to 180 degrees total. And an oblique triangle, you have one angle that's greater than 90 degrees, and the other two are less than 90 degrees, but they still add up to 180 degrees. And again, when we get into your area measurements, you may encounter a triangle or some component of your total measurement may be a triangle, and this will come in handy when you calculate that area for your application. Other common shapes used in construction would be a rectangle, which has four 90-degree angles. Two opposite sides are equal length. A square, 90-degree angles on all four corners, and all four sides are equal length. You may also encounter circles. Your circle is 360 degrees. Some areas may be broken down into a trapezoid shape, which has two parallel sides but no equal length. Rarely you may run across the sector. We're not going to really discuss the sector very much because it's extremely rare to run across that for an area measurement. Other shapes, a parabola, that's not very common. However, depending on the application, you may encounter it. I know one popular example of a parabola in construction is on the Golden Gate Bridge, which has parabolas on each side of the side spans. You may also encounter a parallelogram. The two opposites are parallel and equal side. For volumetric measurement, you may also encounter a cylinder or a cone. But prior to calculating the volume of a cylinder or a cone, you have to determine the area of the circle, which is indicated here in red. In our practical application, problem solving, we'll start with addition and subtraction, and they're probably the most common types of math you'll encounter in construction. So we'll start off very basic with question 1 for addition. If you're excavating a trench to install a pipe culvert with a flared in section, and the total length of the pipe is 24 feet, and your flared in section is 6 feet, you'll need to excavate the trench for the full length of that pipe and flared in section for installation. So you would add those two together to come up with a 30-foot trench for that installation. Again, if anybody has any questions, just type those into the dashboard and we'll answer your questions as we move along. This question for addition has a contractor installing the following items, but at multiple locations on a contract. In location number 1, 792 lineal feet of silt fence, 407 trees, 619 square yards of erosion control mat, 612 cubic yards of topsoil. At location number 2, they will be installing 27 lineal feet of silt fence, 13,040 trees, 113 square yards of erosion control mat, and 212 cubic yards of topsoil. So using basic addition, you would determine the quantity for each the measurement for these items. So for your silt fence, you would add the two together for a total of 819 lineal feet of silt fence. These added together with 13,447 trees. Erosion mat would equal 27,732 square yards of erosion mat. And for your topsoil, that would be 824 cubic yards of topsoil. And this may not come in handy just when you measure your areas to install it, but if these items are shown in a staged construction project and you're bidding this, you can use this to determine your total quantity for these two locations if you're looking to bid on a contract also. Or if you're ordering material for an upcoming installation, you can utilize the addition in these categories to determine your total. Moving into subtraction, have a total of 105 number 8 bars at the beginning of a project. This is for rebar installation. How many bars do you have left after you install 62? In basic subtraction, you would subtract 62, which is what you've already installed out of your 105 total, to have 43 number 8 bars remaining after the initial installation. Question 2, it's for concrete that's delivered. You have 410.19 cubic yards of concrete delivered. However, you only used 401.67 cubic yards. This will assist you in determining how much waste material you have left over. You would simply subtract the 401.67 cubic yards that were used from the 0.19 cubic yards delivered to determine that you had 8.52 cubic yards of waste material left over. This is very useful when you're determining your waste, because if you're looking for a specific yield or to want to make sure that you're calculating your cubic yards correctly, or that you're having accurate delivery tickets on your material, determine how much your cubic yards are that are delivered, and subtract what you've used to determine your yield and your accuracy of the delivery tickets. Addition and subtraction can also be useful when you're determining your workforce information. For example, in a normal workday that's 10 hours long, you have to shut down early because of rain or any other factor. You have a crew of 8, 3 of them have worked for 4 hours, and the remaining crew has worked for 5.5 hours. So how many crew members stayed for 5.5 hours, and how much longer did they work than the 3 who left after 4 hours? You have 8 on your crew that started the day, and 3 left after 4 hours. That leaves you with 5 remaining crew members on the project. The 5 crew members that worked for 5.5 hours and 3 that worked for 4, how much longer did they work? You would subtract the 4 from the 5.5, and it shows that they worked 1.5 hours longer. Moving into multiplication. This is one common type of math that's used on an IDOT construction project. In this example, you're calculating tons of asphalt needed per each station on a project and how much you need for the job. So in this example, you have 34 tons is needed for each station, and the project is 50 stations long. How many tons of asphalt is needed for the job? Simple math calculation, you multiply your 34 tons by your 50 stations. That would leave you with 1,700 tons of asphalt needed for this job. Example number 2, the job calls for drilled tie bars to be installed at 14 different base patch locations. 9 of those 14 locations will use 42 bars at each location. 5 locations will use 36 bars at each location. You would need to know the total number of drilled tie bars to be installed when you're ordering your material. So your 9 locations that use 42 bars, you'll need a total of 378 drilled tie bars by multiplying the 9 locations times the total number of bars for each location. Location 2, 5 locations with 36 bars at each location for a total of 180 drilled tie bars. So using addition, you would add those 2 together to determine that you need 558 drilled tie bars for these base patch locations. Fourth most common type of math used in IDOT construction is division. In this example, you'll be calculating tons of aggregate and dividing it equally among 16 trucks. So if you have 240 tons of aggregate and you want to divide it equally among 16 trucks to determine how much you would load into each truck, you would divide 240 by 16, leave you with 15 tons per truck as an equal load for each truck. Example number 2, paving a section of roadway that requires 1,311.5 tons of asphalt. Assuming that each of your quad axle trucks theoretically holds an average of 21.5 tons per truck. How many truckloads of asphalt would you need to order for that project? You would divide 1,311.5 by 21.5, which would equal 61 truckloads you would need to order for this roadway project. Into fractions, this is a little bit more involved than your addition, subtraction, multiplication, and division. A fraction is a portion of a whole number. It's written as a numerator and denominator, one over the other. And example, 3 is the numerator, 4 is the denominator. So to add or subtract a fraction, you need to find what they call the common denominator. So in this example, 1/2 plus 3/4 equals question mark. So the common denominator would be 4. So you would multiply 2/2 by 1/2 to equal 2/4. You would multiply 1/1 by 3/4 equal 3/4. So then you would add those two fractions together, the numerators, which would equal 5/4. You would reduce that by dividing 4 into 5, which equals 1 1/4. So for this example, to add 1/2 and 3/4, the total would be 1 1/4. That may sound a little complicated, but as we move into the examples, I think it'll explain it a little bit better and give you a better idea of how fractions work. Question 1, you have a drum of curing compound, which is half full, and the second drum is 1/3 full. If you wanted to combine them, how much would you have for your total curing compound? The one drum is half full, the other drum is 1/3 full. Common denominator is 6. So 3/3 times 1/2 equals 3/6. 2/2 multiplied 1/3 equals 2/6. Add those numerators together, which is the number above the line, you would equal 5/6 of a drum. So that would be your total amount of cure compound you would have by combining those two drums. It's also a common math used on construction. We'll just move this example here. If you completed $250,000 worth of work on a project and your total of the contract is 5 million, what percent of the contract dollars have you completed? So you would divide $250,000 by your $5 million, which would equal 0.05. And for the percentage of that, you would multiply by 100. So 5% of the contract has been completed. Example 2, have 105 number 8 bars at the beginning of a project. You install 62 of those. This is an example from an earlier equation, but as a percentage, you would like to find out the original amount, what percentage of the original amount have you installed, and what percentage is remaining. So you would divide 62, which is what you've installed, by the 105, which is your total. That equals 59.1% of the number 8 bars have been installed. A couple different ways to determine this. the way we just did it, or the option one here is take your total at the beginning, subtract the amount that are installed, and you would have 43 remaining. And you divide 43 by the 105 original at the beginning times 100, so that would be 40.9% that's remaining. Or you could take the 100% and subtract the 59.1 to determine the 40. Okay, moving into averages. The width of proposed seating pads in this example is several different locations for 25, 30, 35, 35, 44, 46, 32 feet wide. You'd like to know the average width of these seating pads. We would add all those numbers together, which equals 247. Have 7 different locations, so you would divide 247 by 7 locations. So your average width is 35.285. If you want to round to the next decimal, that'd be 35.29 feet wide as an average width. In example 2, you have an average work week, which is 5 days. So your 8-person crew logs 460 hours in an average work week. And you want to know the average hours per day that each person works. So you would divide the 460 hours by the 8 people, which is 57.5 for the total per person. Divide that by 5 days. So each person on your crew averages 11.5 hours per day. This can be especially useful if you're calculating moving into your payroll periods, or if you're looking at bidding the project and looking at workforce required to get the work done on your average time frame that may be specified in the contract. Okay, as I mentioned earlier, stationing is not typically associated with basic math for construction, but it's a fundamental measurement that they use for road layout in construction. There are reference points that are typically placed along the route, either on the center line or the edge of pavement or baseline at some regular interval. Typically, the interval is between stations is 100 feet. For these examples, if you start at station 0 plus 0, 0, and you go to 1 plus 0, 0, that's 100 feet. Station 0 plus 0, 0, and you're going to station 1 plus 25, that's 125 feet. Station 0 plus 0, 0, and you're going to station 1 plus 50, that's 150 feet. We'll have more in-depth information on stationing in the basic math module number 2, which is Thursday this week. And we'll go a little bit more into how stationing works and how you can use that for measurement. So if you have the beginning of a project at station 103 plus 45, and the end of the project is 1,245 plus 85. How long is this project in linear feet, and how long is it in miles? The 1,245 plus 85 minus 103 plus 45 equals 1,142 plus 40 stations. I'm gonna use it as a decimal, 1,245.85 minus 103.85 is 1,142.4 stations. And using the station as a 100-foot interval, you can take 1,142.4 stations times 114,240 lineal feet. And to convert that to miles, 1 mile is 5,280 feet. So you would divide that number into your total 114,240, which is 21.63 miles long. Typical measurements and conversions that you may encounter. Just listed them here. For example, 6 inches is half a foot, 0.5. 1 foot, 12 inches equals 1 foot. Construction, they typically don't use inches in measurement. Most engineers use what they call an engineer's tape, which is calculated in tenths of a foot. So first example for inches, 0.5 feet. On an engineer's tape, it would show 0.5 and then 1 for 6-inch increment, half a foot or a foot. So each foot is broken down into tenths of a foot, which comes in handy when you're using a calculator to multiply and add your partial measurements. Here we have some common measurements and conversions for volume as well as weight. I have height measurements listed here because it is common in some applications. For example, if you're calculating the column of a bridge or bridge clearance from the roadway surface to the bottom of the bridge, light poles, storm sewer manholes, you may need those height measurements depending on what your application is or your specific contract. So with that, are there any questions?
Ron, I haven't seen anybody type in any questions in the Q&A at this point.
Okay, well, if there are no questions, you for what's included in basic math 2. We'll cover equations and problem solving for square yard, cubic yard, area, and more. We'll definitely get more into stationing and how that works on a typical construction project and how you can utilize that when you're calculating material or looking into bidding. So we'll invite everybody to join us for basic math 2. I see we have a raised hand. Teresa Kern, you have a question?
Can you hear me?
Yes.
Oh, thank you. We have bills of lading. We install rebar. Ever.
Can't hear you now.
I don't know, I can't hear Ron, can you?
No, I can't hear her now.
Another option, you could type it in the Q&A or even in the chat if you want, what your question is, because we can't hear you.
Or you can email it to either myself or Dave Clark with ESI Limited. Our email addresses are here as well as our cell phone number. So if you have a question that comes up either now or we can't hear you, or get the message included in the chat, or feel free to contact us anytime with any questions related to the presentation.
It don't say nothing. If she don't have her paperwork done by Friday, I'm going to put that 4-bedroom on the Section 8 list, and the walls probably don't look bad, that somebody else would be okay with it.
No, they don't. This
Here's a full list of the technical supported service consultants available for districts 1 through 9. So pick one that's convenient for your area. Feel free to contact us with any questions related to technical supported services, any of our upcoming workshops. Or if you have any input, feedback for presentations that may help us improve our services.
was up yesterday when that lady pulled up, she said her construction company and all that stuff. But she's there.
This presentation is being recorded, so you should receive either the presentation in an email or a link to the presentation, and this information for the contacts will be included with that. So if you don't get the number or email recorded right now, don't worry about it. They'll get that to you later.
Ron, I might add on this final slide there that ESI does the technical services all over the state of Illinois. So no matter what district or area you are in the state, you can contact us and we can find somebody that can help you. We also have the 3 subs, Oneida Engineering Solutions, and they work for us up in districts 1 through 3. Herman and Associates, they're out of the Peoria area, but they help us in districts 4 through 6. And then EFK Moen, they're down in the District 8 area, but they're able to help us in District 7 through 9. But, feel free to contact any of us. If you're not sure who you want to contact, get a hold of Ron or I1, and we'll be more than happy to get someone that can answer your question and someone that's probably close to where you are at. So just keep in mind, we're here. It's just a matter, you got to let us know if you have questions or issues that you need help with on a technical side. If your question turns out not to be in the technical nature, there is a management consultant also that handles a lot of the things like for, if you're using accounting softwares and so forth. And we'll just refer you to them. We'll get them in touch with you. And if you have a certification question, there are certification consultants that we would put you in touch with. But you just need to get a hold of us and let us know what your questions might be. Keep in mind, there is a letting that is out currently, and the bids are due later this month. So if you need any help with your bidding, contact us as soon as possible. Don't wait till the last minute. Ron, that's all I got.
Thank you for that, Dave. There are no questions with that. That'll conclude our basic math module 1 presentation. And again, please join us for module number 2, which will be this Thursday at 10 a.m.